Good evening and welcome to Front Page. Tonight, we're talking about a company with a name you won't forget, Digantara. In Sanskrit, it means the space between directions. And that's not just poetic, because Digantara works in a space where governments are suddenly paying very close attention to using satellites, not just to watch what's floating in orbit, but to understand what could become a threat on Earth. Digantara began by tracking objects already in space. Today, they're moving into something far more consequential, detecting and tracking threats before they arrive. Joining us is Anirudh Sharma, the founder and CEO of Digantara. His company has just raised a $50 million Series B funding at a moment when governments worldwide are rethinking how space security and early warnings come together. This conversation that we are going to have with Anirudh is not just about the funding headline. That will obviously be a part of the conversation, but it will also be about execution, defense grade technology, and what it really takes to build space intelligence that governments can rely on. Anirudh, a big warm welcome to you on Front Page and a big congratulations from the entire Front Page team on this funding.
Thank you so much.
We are thrilled to have you with us. So let's just start off as far as the timing is concerned, Anirudh. So over the last 2 years, space has very quietly moved from a research domain to a very core defense priority. Budgets are rising, programs are accelerating, and governments are thinking long term. So, in terms of this particular time aspect, you've raised $50 million when governments globally are increasing investments in space based surveillance and missile early warning systems. So, what does this round unlock, Anirudh, strategically for Digantara, and why right now?
I think predominantly two things. The first thing is given the capital that the sector itself needs for us
Hmm.
to go from just building a prototype to scaling a model, that is enormous. And I think at this point in time, given we have already launched satellites to space, we have tested our systems both on sensors and softwares. Now it's time for us to scale. And I
Hmm.
think scaling doesn't really wait. And it is also important that we put up satellites at the right time, given everything that's happening geopolitically all across the world, be
True.
it war in Israel and Ukraine right now.
Hmm.
So all of this is playing a very important role in shaping budgets for these governments. And it is
Hmm.
important for us to scale at the right time for us to be able to tap into those programs and budgets. That's one. The second thing is the most important thing that we've seen after all these wars is that every
Hmm.
country is moving towards building its own sovereign solutions, which means
Hmm.
they want to own a capacity, they want to basically be able to control that capacity, and they want to make sure it is done within the country or within the nation that is purchasing it.
Sure.
And that's where the sovereign angle comes into picture. So, given everything that happened, be it Operation Sindoor for India, there was
Hmm.
a surge in terms of demand for anything that is defense related technology that can provide either intel or aid in any operations.
Hmm. Hmm.
So we were at the right time, right place for us to be able to encash such an opportunity. Hence, we looked at raising a bigger amount of fund, not just to pursue what we were doing before, which is space domain awareness. We would eventually continue to launch satellites on space domain awareness, but beyond that, we also had to enter into adjacent domains or evolve ourselves from the
Sure.
technology that we have built, and also ensure that again supports government programs and also
Hmm.
strengthens capability for any country.
Fair enough. I mean, Anirudh, makes sense in terms of the fact that you have drawn on all of the experience, the fact that you mentioned that you've launched your satellites, etc. And now the time is nigh for this particular technology in assisting as far as things are concerned world over and the volatility of it all. But when companies, Anirudh, expand into defense adjacent capabilities, the word pivot generally obviously comes to the front of the mind. And what starts happening is, for example, in Digantara's case, the technical through line seems very, very consistent. Digantara began with space situational awareness, as you just mentioned to us and the audience, and has now expanded into missile detection and tracking. So, how do you frame this shift as an evolution of core capabilities rather than a pivot, or is it based on what the environment suddenly has thrown up?
I think this has always been a pathway for us. And the reason I say that is because fundamentally, forgetting the fact that we do space domain awareness, fundamentally, what we do is track fast moving objects. And
Mm-hmm.
in space, we are talking about objects that are moving at 7 to 10 kilometers speed of, 7 to 10 kilometer per second speeds, or
Sure.
15 times the speed of bullet.
Mm-hmm.
So we're already tracking literally fast-moving objects, hypervelocities, and we
Mm-hmm.
have built an algorithm, we have built a sensor that can aid us to do all of what we want to do in terms of space surveillance. Now we want to apply, or we are applying the same physics principle. The underlying principle still remains the same for missile tracking. It is
Sure.
just that we're looking downwards.
Mm-hmm.
While we were tracking space objects, now we are tracking hypersonics or missiles.
Fair.
So the sensor stack would remain the same. The wavelength at which we're looking at doing this detection is different. Image processing is more or less the same as what we were doing for SSA or space domain awareness that
Mm-hmm.
we are now evolving for missile applications. So I would say it's more of an evolution. Also, given the fact that every space company across the world right now have to be cognizant of the fact that most or a huge chunk of their revenues would come from governments. It's
Sure.
important for us to also act accordingly in terms of the market shifts and market needs and demands. And we've seen a very clear example of that during Operation Sindoor. And at the same time, I think the United States government has been talking about the Golden
Mm.
Dome, which is Trump's flagship program. So all of this led us to building a thesis towards, something like a missile tracking, missile detection, given the fundamentals would remain the same.
Oh, fair enough. Which essentially means that the core technology, as far as Digantara is concerned, is now only maturing to handle a lot more. It's just an evolution which is taking place. This also actually brings us to the limits of how defense systems have traditionally worked, Anirudh. Ground-based systems have done the job for decades. We are all aware of that. But the threat profile, as you had mentioned, has changed and has changed radically. So, space-based IR and optical sensing changes the equation. What advantages do space-based systems offer in detecting hypersonic and fast-moving threats vis-a-vis the traditional methods?
The first thing is when it comes to traditional radars itself, it has
Mm-hmm.
a lot of limitations, one of which is Earth's curvature itself. It cannot see beyond certain horizon.
Yep.
That's one. The second thing is atmospheric attenuation. If the weather is bad, it doesn't, we cannot detect a certain system.
Hmm.
Now, there are three parts to a missile phase, I would say. I will just make it very simple. The first part is the boost phase of the missile or the launch phase
Hmm.
of a missile, where a missile gets launched. The second is the free flight phase, where missile is now moving. The last part is re-entry,
Hmm.
where it has to enter a particular location where it was designed to, enter.
Hmm.
Now, the re-entry phase of missile detection and even interception is solved through radars.
Hmm.
And we saw that happening during Operation Sindoor with S-400s.
Yeah.
But the boost phase and the free flight phase is where the gap is at this point in time.
Hmm.
Which means while interception is happening still at a radar level, at a re-entry level, it is very much important for us to ensure we provide intelligence of where a missile is getting launched, which trajectory it is following, and when would
Hmm.
it hit a particular location.
Hmm.
And that is the gap that we are trying to fill with space-based sensors. Now, space-based sensors is global in nature. We don't have to look at a particular location of any particular place on Earth.
Hmm.
It's mostly a constellation of satellite that we have distributed in orbit that's looking at your area of interest based on your constellation design. Now
Hmm.
you can ensure there is something that is doing 24 into 7 surveillance of that particular location for you. so that if there is any takeoff of a missile,
Right.
or if there is any incoming missile coming towards you, you know much before, so that the interception can happen much more efficiently than missing at a particular location, like
Hmm.
we've seen again in Operation Sindoor.
Yeah.
So that is something space-based system or space-based IR sensors
Hmm.
in a constellation can solve for, which today traditional systems haven't been able to solve for. And I think the word that I like to use is deterrence. We will just improve
Yep.
how we are looking at security by adding more capabilities that only helps us to be prepared in a much better way than we could have done through a radar.
Which is, I mean, amazingly crucial that you brought out that fact, Anirudh. Deterrence. I think, yes, that is the operative key word and takeaway from that. And I am pretty sure that your technology is going to be able to assist in achieving that. Once actually you move from a few satellites to a full network, Anirudh, everything, which is basically manufacturing, launches, data handling, gets exponentially harder. So you're planning a constellation rollout, as you just mentioned, through 2026, 27. So what does execution at this scale involve technically and operationally?
So I would like to say, basically, this concept of prototyping,
Mm-hmm.
all our lives so far, what we've built are systems that could be, prototypes that we have launched to space that did work, and it was more like a technology demonstrator. We had to prove that this technology would work even if we launch it to space.
Sure.
Now it's time for us to scale from one to, let's say, hundreds of systems.
Hmm.
So in our case, we're going from 1 to 15 and in terms of space situational awareness satellites, and another two missile tracking satellites is more of a technology demonstrator that we are launching to orbit. Now, what
Mm-hmm.
changes is before we were focused on just building one satellite and we were doing sequential build of these systems.
Hmm.
Now we have to get to parallel build. And the North Star that we're trying to look at is basically the first satellite required a lot of R&D. We had to put in a lot of man hours of engineers who could build this particular satellite. Now we are
Sure.
moving towards technicians being able to build it. We'll have to
Nice.
make this satellites like a stencil. So it's
Mm-hmm.
more like, automotive industry where you have figured
Right.
out how a car runs. Now it's for technicians, a bunch of technicians to build another car, and there is no
So is
rocket
it
science
more
in it.
like an assembly line methodology that you're alluding to, Anirudh?
Yeah, yeah. So more like a production line where we're
Mm-hmm.
looking at parallelly producing these satellites. And today we can handle a capacity of 5 to max 6 at a time. We would want
Mm-hmm.
to get to 30, depending on how the
Nice.
demand is from the government. And truly, nobody ever beyond SpaceX has
Hmm.
achieved scaled production of satellites where you can churn,
True.
let's say, tens to hundreds of satellites in a week. And
You
and
know,
this
if we,
part of the world,
sorry.
yeah, yeah. So in this part of the world, it's even more crucial for us to do it because at any given point in time, we are still dependent on American or the Western technologies. And I see a huge gap for somebody like us to play that role of becoming an Anduril or a Lockheed Martin equivalent in this part of the world. And that's how I'm looking at this production line to aid in terms of not just solving space domain awareness or missile problem, but going forward, this can itself turn into a business unit.
Wow, this is fascinatingly encouraging and inspirational, Anirudh. And of course, wishing you and the entire team all of the best and all of the luck and all of the positive energy. But before we move on, I need to ask you this, and this is from our audience's point of view. What are you planning to roll out? If you could just maybe share the details with us, maybe a little bit, and by when?
So we're looking at launching 15 satellites for space domain awareness. What
Mm-hmm.
this basically does is tracks every single object from low Earth orbit to geostationary orbit in space. Traditionally, again, the systems that are used are ground-based, either telescopes or radars. We're
Mm-hmm.
complementing what's already available with a space-based network so that, let's say, a ground-based system is tracking an object once a day. We would like to go to 4 to 8 times a day so that
Uh,
we increase the cadence of tracking a particular object, which means the catalog or the library that we maintain has a better update rate. That's
sure.
one. And this 15 satellites we're looking to launch before the end of 2027, December.
Nice.
And we have a launch planned in the month of March on
Mm,
SpaceX, June,
mm,
then October. Every quarter we have one launch planned, and then we will do a constellation together. The reason we're not doing it in one single go
mm-hmm.
is because we want to place this in different orbits. We're looking at an orbit called dawn dusk, where we almost always have sun's illumination for us to be able to track objects because we are doing passive tracking with these systems.
Nice.
And the next variant of satellite uses a LiDAR, which allows us to do active ranging, and we don't have to be always dependent on sunlight. So these are
Mm,
different configurations of satellite that we are launching, and the another batch of constellation that we're launching is basically to equatorial orbit, so that we look from equatorial planes towards geostationary orbit, so that we track from, let's say, 500 600 kilometer to 45,000 35,000 kilometer. So these are different optics and optical sensors that we're using for us to be able to do sensing across different orbital regimes. And
hmm,
one other
hmm,
initiative I think that we did announce was also doing the same thing for lunar orbit,
hmm,
because we have seen a lot of conjunction or collision warnings in lunar domains, and lunar domain has become a very important domain for military. And US
hmm,
government runs programs at this point in time to monitor traffic between Earth and the moon,
hmm,
for
hmm,
them to see which adversarial country or a nation is now launching satellites to moon, because
hmm,
the next phase of let's say launching of missiles may not happen from ground, it will happen from space.
hmm,
At
hmm.
that point in time, you would want to ensure there are no operational surprises, and that's something that we are solving for across orbital domains.
Very nice. Anirudh, of course, the way you've explained it to us clearly talks about the fact that it's a very planned methodology that is being followed for achieving a holistic view for sensing in terms of all of the different orbits that it's being launched into. Sounds exciting, and of course, wishing you all the best for the launch, you and the team. But now let's come back to Digantara for the aspect that you also operate across two very different ecosystems. India brings engineering depth and cost efficiency, Anirudh. The US brings defense customers, procurement scale, and regulatory complexity. I would like for you to maybe shed light on this. India and the US to meet defense and regulatory requirements. It's one aspect. So, why is this split critical? And
Um,
how are the
yeah.
two operations differentiated?
Again, I think it's mainly because of the fact that every country is now looking at building its own sovereign capability, and they don't
Hmm.
want to be dependent on each other. So they
Hmm.
encourage their own companies to build capacity for them. Just
Hmm.
like today's SpaceX is basically critical asset for the United States, and any rocket capability, be it ISRO or a bunch of other private uh, launch vehicle companies, are highly important for the Indian government. So this particular case of building entities which basically doesn't talk to each other or builds different technologies was very important for us to serve the interests of local governments. And it's also mainly because of regulatory reasons and the sector that we operate in. For
Hmm.
example, in India, we can have sensors on ground that does tracking of space objects, but can
Sure.
we share data from that particular sensor, let's say somewhere in Uttarakhand or even Gujarat,
Hmm.
to an
Hmm.
American customer of ours? No, we can't,
Hmm.
because
Hmm.
we're violating certain guidelines that Indian government has at this point in time.
Right.
Similarly, for the US, we cannot do the same, where we have sensors in the US, or we operate satellites as US owned satellites and still sell the data to another country unless we have regulatory approval from the US authorities. Now, this
Hmm.
was more of a market access mechanism for us to separate out the entities so that we abide to local regulations, and also ensure we follow what the guidelines has to say in any country that we are setting up our entities or serving to that particular
Hmm.
defense agency so that there is no mistrust. And this often happens in this particular sector. And I think we've always had a playbook in the past, like Boeing today operates out of Europe, Airbus operates also out of the United States. So there are,
Yeah.
multiple ways of you doing business in multiple countries. It's
True.
just that you would have to ensure you follow local regulations. And the most important thing why we looked at the US is because even today, the largest
Hmm.
share of satellites in orbit is from the United States, and the largest budget that is invested into
Sure.
defense or space sector is from the United States. So we had to have a presence in the US for us to be able to get at least some part of that particular market from United States that we can work on. While we have an emerging market in India. India for the longest time
I was
had
actually just going to
army.
come to that.
I mean, we had Army, Navy, and Air Force. Now we have Space Force equivalent agency in India called Defense Space Agency, which is now looking at procuring solutions for space military aspects. And
True.
we're just seeing that new movement in India, and we don't also want to miss out on what's happening here. Hence, I think we had to split our entity, and this was a very cognizant move where we hired Americans there to work on different programs that we've got from the American agencies in India. We're working towards
Hmm.
all Indian defense related contracts.
Anirudh, very quickly, I would like you to probably remark on this that deep tech funding in India is something which is taking on momentum now. I believe, of course, we are still well lagging behind as far as the research aspect is concerned when it comes to deep tech, but space tech is doing fabulously well, or at least it's growing exponentially. What do you have to say to that as far as the India ecosystem is concerned?
Now, I personally think it's a wave at this point in time where they're
Hmm.
seeing a lot of companies emerging in this particular sector, and hence, they would like to invest money into new business models, innovations. But I
Hmm.
think the first batch of companies like ourselves and few others, they would have to do significantly well and build investor interest for the next batch to be able to raise growth funding.
Fair
Today,
point.
I think pre-seed and seed funding is solved for
Hmm.
because of two things. One, government's push towards deep tech. And the
Hmm.
reason I say that is because I think government did announce RDI funding,
Yes.
where government becomes an LP and any fund manager in India can apply and get money as far as he's investing in deep tech.
Hmm.
So that makes even other VCs or investors who weren't part of
Hmm.
deep tech before to
Hmm.
now invest in deep tech for them to get
Hmm.
that particular LP.
Hmm.
So that is also, sort of helping deep tech, be it space tech, semiconductor, even biotech, get a lot of
Hmm.
funding, which is again early stage. But what is still missing in India is that growth stage funding. And I'll give you an example. In our case,
Please.
while we were doing this round, we had two choices. One, either raise a growth round from abroad, which will
Hmm.
increase the foreign shareholding within our company,
Yeah.
or find an Indian investor
Hmm.
to ensure we still are an Indian company so that we qualify for all government contracting within India. And because last couple of years, defense has really moved towards Make in India, and their
Yeah.
eligibility criteria have changed, which means we require growth funding in India. And we've
Hmm.
seen the same reflection in public markets. Public markets, at least defense sector, is doing quite well
Yes.
also because of all the incidents that's happening where government is now investing a lot of money. And all of this, I think, is like more or less like a signal for investors to invest in this sector. And again, this is just a signal. There is no
Hmm.
heuristics for startups yet.
Hmm.
So what becomes very much important is how the first batch of companies perform, not just in terms of building tech, but also in terms of being able to build a sustainable business. And is it scalable or not? Is still a question that one of us have to answer as we grow.
But I think you've answered it well enough, to be honest, Anirudh. I think it's a very pertinent point that you've made. That genuinely, if the leaders in the ecosystem are doing a lot more robust work, it will just create that sense of ease and confidence as far as the investors is concerned to come in and start to really make sure that the ecosystem starts to flourish moving forward for the new startups which are coming through. Which of course brings me to this: with defense contracts already in hand and a very clear revenue roadmap, what gives governments confidence, Anirudh, to commit to long-term programs with Digantara?
I think the fundamental point here was the fact that there was no alternative
Hmm.
for the government, at least with the solutions that we were developing.
Mm-hmm.
That's one. The second thing is that they did see foreign agencies and governments approach us and purchase these solutions.
Hmm.
So these two things led towards fast tracking certain procurements which never happened in the past in at least this sector for the defense forces or agencies, to basically build confidence in giving orders to companies like ourselves.
Hmm.
And the last thing that I would like to mention is, like you again mentioned in your last question, we still lack in a lot of fundamental R&D.
Hmm.
Nobody in this, um, at least in this country, is yet looking at funding TRL 1 to 3 and then TRL 4 to, let's say, 7 and 7 to 9. There is no TRL progression based funding yet,
Hmm.
which
Hmm.
means all these agencies, all the agencies within the armed forces, be it Navy, Air Force, Defense Space Agency, Army, look for end products. They would
Hmm.
want products as of yesterday without investing in fundamental R&D. And in our case, I think timing was something that did work. We started doing space domain awareness when it was just a thing in the United States back
Hmm.
in 2019, 2020. And
Hmm.
it took us at least 5 years for us to be able to put in our own capital, develop technologies. And now we are seeing the end of the tunnel or the light where we are able to,
And you deserve
encash on
every bit
all
of
the
it, to be
R&D.
honest, Anirudh, because that I'm sure would have been a tough time for one to put in one's own money, build that
One's
runway.
own money without any confidence, will Indian government purchase this?
True.
And that is happening to a lot of other startups at this point in time. And that's where I feel it's very important for you to do business and tech hand in hand. I don't want any deep tech or a space tech company to just remain a research laboratory, because a lot of
Sure.
companies start and then remain R&D center, but they would
Hmm.
never think like a commercial company. And that's a gap that I see between us and the United States based startups or companies.
What would you like to say to the government at this given point in time? I mean, you've said it, but I would like for you to say it directly as well.
I think government has done really great in terms of promoting this sector,
Hmm.
which means the positive signaling where we are able to attract investors and all of that. Government is doing a lot of good things. Like the Prime Minister himself tweeted when we launched our previous satellite, and that gave a lot of inroads into certain defense agencies when they saw that as a credible source, and they saw that as credibility for us to, even have a discussion towards getting an order. But what is
Hmm.
still not solved for is this um, nature of being very reactive, which
Hmm.
means given Operation Sindur happened, we'll have to do XYZ procurement, and something else happens, so we'll have to start procuring 10 different stuff. If we do that, let's say in 10-year horizon, we will never build capacity or any capability within the country. At any given point in time, we will still be dependent on France, Russia, or one
Yep.
of our partners.
Yep.
And for that to change, I think you'll have to build a roadmap, be it a 10-year, 20-year roadmap, to even understand what kind of foreign policy do we have and what are the threats that we think we should address and how, and what are these
Hmm.
capabilities that we should have as a country. And that can start from even having our own engine, aircraft engine, or having our own satellite manufacturing capability, or
Nice.
having systems that can basically intercept missiles than purchasing
Hmm.
it from Russia. And that, I think, is true independence you can achieve once you start investing in fundamental R&D, and that has to happen outside of government laboratories. And I think we have reached a phase where government can now trust private entities as one of theirs and invest in capacity development with these private entities. Today, just to tell this fact, NASA
Sure.
doesn't have their own rocket. They are still dependent on SpaceX, which means US did invest not just in SpaceX but 10 other rocket companies to
Hmm.
ensure there is capacity at any given point in time. There is no single point failure within their capacity and within their country for anything that they want to do in terms of launch. But in India today, if ISRO doesn't do anything, there is no active rocket that can take anything to space. So I think we'll have to start de-risking a lot of these capacities and capabilities over a certain horizon, and having that roadmap at a leadership level of this particular country is very necessary for any startups to even understand how do we scale the company within this country. And again, we had a choice of either being a US company or an Indian company. We
Hmm.
chose to have our headquarters in India.
Hmm.
And that was
Wonderfully.
because we were, again, we were very much fortunate to get a lot of opportunity to talk to the top leadership and build that confidence that it's okay, it takes
Yes.
time, but I think we want to build from here. And I want this to be at least spread across the ecosystem so that even others understand what kind of footsteps do we have to follow and what is the roadmap that the country has so that we build this capacity for the country.
Wonderfully, wonderfully put, Anirudh. I think, in a nutshell, if I were to put it across, it's very simple. We need to be stop being reactive. We need to be forward-looking as a country, as a policy, and of course, as the entire ecosystem is concerned. And the fact that we are so happy that you've taken the call of headquartering your operations from India, and I believe that that was possible because, I guess, people are listening and people are listening as well to your final message. So I'd like you to give a final message, of course, moving into 2026 to everyone who's watching, people who matter.
I think there are two things that I tell in all of my internal meetings, which basically led Digantara to wherever we are at this point in time. That two things is resilience and perseverance. These are two things that is very important when you're in a sector like this because you have to build a lot of patience to even see some success, let's say after 5 years or 10 years, but ensure you have these two things in your journey.
Thank you so much, Anirudh. It's truly been very, very inspiring speaking with you. This is, of course, wishing you and the entire team at Digantara, and thank you so much for taking all of us on front page and the audience into the offices of Digantara with that little message of yours of resilience and perseverance, and wishing all of you the best moving forward. May the year 2026 be filled only with joy, achievement, and all of the launches. May we wish you a wonderful takeoff.
Thank you so much for having me.
Thank you so much, Anirudh. Well, ladies and gentlemen, I was Anirudh Sharma, who, of course, spoke so well and so truly about so many aspects, which I believe he has learned from experience. He's learned from the sheer perseverance and the resilience that him and his company have had to take on as a journey. Today, he is, I won't be wrong if I say he's one of the old guards as far as the ecosystem is concerned, and he is helming that responsibility with a lot of care and awareness, building probably a roadmap for the newer startups to come in. But clearly, the point is that India is definitely in a wave when it comes to deep tech and space tech, and it's a good thing. But I believe we don't need to be reactive. We need to build pipelines. We need to have policies which allow for all of us to one day be ready to sit in the front row seat when it comes to space tech and deep tech and constantly building from there on. Ladies and gentlemen, this was Front Page by AIM Network. Like, share, and subscribe. Think AI, think space tech, think AIM.